Hi students, this is Muhammad Ali. I'm glad to be your instructor for this course. We will use the University Physics with Modern Physics, the 15th edition. Okay, we will start with the chapter number 1, which is units, physical quantities and vectors. To know more about the nature of physics and how the physics is developed during the years, and also how to solve the physics problems, you can see good videos on Canvas. I put them in the blog for the first lecture. And for the solving physics problems, we will deal with many problems and examples in the future, and you will be more comfortable with these regimes. And we will start now with standards and units in physics, which is in page number 3. In physics, we need to deal with different quantities. The mass, the speed, the force, all of these things are quantities. For example, we need to know at first that we have two kinds of quantities: fundamental quantities and derived quantities. We have 7 fundamental quantities, just 7 fundamental quantities in physics, which are the length, the mass, and the time, the electric current, which is in ampere, temperature, which is in Kelvin, not Fahrenheit, it is in Kelvin, the amount of matter, which is in mole, the luminosity, which is in the candela. The first 3 quantities, which are the length, the mass, and the time, are the most important quantities for us in this course. The length is the measure of the distance between 2 points, and you will see the scientific definition, modern definition, in the next page, which depend on the speed of light to measure the 1 meter, which is the scientific unit to measure the length. The meter is the unit to measure the length, not the feet. Also the mass, which is measured by kilogram, not by pound. And you can also find what is the most accurate definition for the mass in the next page, also in the next page in the book. And also the time, which is measured by the second, not hour, not minutes, not days, it is second, just second. So the main quantities for us is the length, the mass, the time, are measured by meter, kilogram, and seconds. Okay, the derived quantities, we have many derived quantities, not just 7 or 3 as we see for our course. For example, we have the area, the volume, speed, velocity, the density, the acceleration, the force, the energy. All of them are derived. What is the meaning of that derived? The meaning of that we can derive this quantity from a fundamental quantity, but we can't derive a fundamental quantity from any other fundamental quantity. For example, we can't derive the length from the mass or the time or any of these quantities, but we can derive the area from the length, which is meter by meter, which is square meter. We can measure the area of this surface, which is x multiplied by y. X is a length, y is a length. We can see that later in the examples. Also the volume. The volume is a third dimension to our area to be volume. In this case, for example, we have Z. So we have meter cubed. Meter cubed is equal to meter by meter by meter. So we can derive volume from the length. For example, the speed or the velocity, we will know what is the difference between them. It is meter per second. If we divide length over the time, it will be meter over second. This will be equal the velocity or the speed. The density, the mass over the volume, kilogram over a derived quantity, kilogram over meter cubed, will give us the density, and so on. We can derive the derived quantity from a fundamental and or derived quantities. Also, we have another criteria to find or to know the sorry this is Fahrenheit, not Celsius. We have different systems of reading the units. We have English or British or US unit system, and we have the international system units or scientific international system units, or the French, which is the French system of units. Here in US, you measure the length using an inch or a foot or a mile, but this is not a scientific system of unit. This is the scientific international system of units. You measure the length by meter, and the derived quantities from, or the derived lengths from the fundamental quantity, which is the meter, is the kilometer or centimeters. This is the fundamental quantity or the scientific quantity. Also the mass. We measure the mass using the kilogram, and the gram is derived from a kilogram. But in English unit system, we use pound or ounce. For example, we measure the temperature using Fahrenheit in USA, but in scientific system of units, we measure it by using Kelvin degree. Sometimes we use centigrades or Celsius. Okay, we will see in different examples in the next section how to deal with these things. In the book, in page number 4, you will see in details the most accurate scientific definitions for the mass and the length and the time, depending on a universal constant, just like the speed of light, the Planck's constant, and the atomic properties for some atoms. This will give us accurate definition for these quantities, and these 3 quantities are the most important for us in this course. Thank you.